Electron beam incident on a diatomic molecule. A uniform beam of electrons of momentum p moves in the x direction and scatters from diatomic molecules that are aligned in the x direction. The diatomic molecules can be approximated by a model consisting of two identical scattering centers paced at distance d equals 3 times a along the x-axis as shown above at left. One atom, one half of the molecule, alone produces a scattering intensity as a function of angle as shown above at center. The diatomic molecule gives a scattering intensity as shown at right. Extend the scattering diagram for the diatomic molecule over the complete range of angle to 180 degrees by an approximate qualitative sketch. If the energy of the electron beam is increased by a factor of 4, show qualitatively how the scattering curve will change. What is the energy E in electron volts of the electrons producing the scattering curve in A? Answer. A. Path length diff equals d minus x sub 1 equals d times open paren 1 minus cosine theta close paren, and x sub 1 equals d cosine theta. Minima.
See the equation. Maxima. See the equations. Thus, we have maxima. See the next equation. Here's a sketch. B. If E equals 4 E sub 0, the P equals TK equals 2 P sub 0 semicolon K equals 2 K sub 0 semicolon enclosed with box DK equals 2D, and the new condition for maxima is theta sub M equals the inverse cosine of open paren 1 minus M over 4 close paren, so there are approximately twice as many maxima. C. The energy is.
See the equations. Thus, approximately 68 eV.